Recently in class, we talked about tests of significance. In this video, I wanted to start off with a quick recap of the fundamental ideas, and then we will work on the try it yourself from our lecture notes for this week and try to put all of that information into practice. So just to do a quick recap of what is a significance test and then how do we do it, there are fundamental components of a significance test. First of all, we have the null and alternative hypotheses. And this is kind of the two logical conclusions that we're going to come away with from our test. The null hypothesis is always the claim behind what is sort of the theoretical value of the mean, or, you know, in future chapters it might be referring to something other than the mean, but for now, the mean. And then the alternative hypothesis is kind of what we're looking into. Is it different from the mean? Is it larger or is it smaller? And what you can remember about from our class is that the null hypothesis, also labeled as H sub 0 for null 0, is just another word for that, and H for hypothesis, is that it's always testing, we're always testing equivalence that the mean is equal to something. So like, for example, in class we looked at a theoretical problem where the claim was that the mean test score for the GMAT was 550. And the researcher wanted to determine if her population was actually less than the mean, or something like that. So let's look at our current try it yourself to try to put an example to this. Let's go ahead and read it and try to figure out what is the null and alternative hypothesis. So it says, the National Center for Health Statistics reports that the systolic blood pressure for males aged 50 to 59 has a mean value of 130 with a standard deviation of 15. The medical director at a large company looks at the medical records of 72 executives within the age group and finds that the mean systolic blood pressure in this sample is 128.07. So this is always the key thing with a significance test, is we have a claim and we have an actual result from our data. And our goal is to determine, well, is there a significant difference from the claim and the actual? Like here, the claim is that which is a report from the National Health Center, the claim is the average is 130. And in the sample from executives, we get an average of around 128. So the question is this a significant difference or not? Upon looking at the difference in the numbers, it doesn't really seem particularly different, but a lot of times we want to, like, let's say we wanted to come to the conclusion, the systolic blood pressure of the people that work at my company is less than the average. And the question is, should this medical director, can he make this statement about his 72 executives? Clearly it is less, but is this significant or not? That's what we're trying to do with the significant test. And if he were to claim it is significantly less or it is actually less, how do we know if that's correct or not? Because one of the key elements we've been discussing for the past couple classes is, well, there's always an element of randomness to a random sample. So again, if we're taking a sample of 72 executives, we get a value of 128 for their mean. But the question is, does that actually represent the true population of those executives? Because as we know, when randomness comes into play, that could be lower or greater than the actual mean of the population. And a sample doesn't always 100% reflect exactly what's going on. And that's always the idea behind a significance test. So to try to keep it simple, let's just try to focus on the key aspects of the significance test, which again, starting with the null and alternative hypothesis, can help us understand, okay, what is it we're trying to do? So the null hypothesis, as I said earlier, is always a statement. So remember, the null hypothesis is always a statement about the mean of the population, not the sample. So, and it's always a statement of equality. So this is something that you're going to have to learn how to kind of figure out, okay, what is my null hypothesis? But remember, it's always a statement about mu. And kind of a key thing to remember is the claim is that the mean is 130. And this is what is going to be our null hypothesis. We want to determine, is this true or not? And another thing about significance tests is we never can actually come to a complete conclusion because we're always making inferences about data. But there's always like a % chance that, you know, we're trying to understand the situation with regards to. And remember, X bar, we're going to use this to make determinations about our actual about our null and alternative hypothesis. And then the alternative hypothesis is always there's always three cases, either going to be a one-tailed test or a two-tailed test. The mean is either we're either going to try to see if, well, alternatively, is the mean less than 130, is the mean greater than 130, or is it just different from 130? And they're all pretty much, the math that goes into that is pretty much the same anyways, except for when it is two-tailed. But again, the thing that if you're trying to determine, well, which direction is it less than or greater than or not equal to, you should be able to determine from the wording of the question. But looking at the actual mean that I obtained from my sample, we might be under the conclusion that, okay, maybe their blood pressure is less than the national average. But again, you can't look at the results from your sample before you test the hypothesis. You'd always want to know ahead of time. And notice that it actually asks in the question, is this evidence that the company's executives have a different mean systolic blood pressure from the general population? Notice it doesn't specify less, it just specifies different. And that's why we'd want our alternative hypothesis to just be that the mean value is different from 130. So again, sort of summarizing, what does this mean? The null hypothesis is always that the mean is equal to something. And in this case, the null hypothesis, like there's some claim that we're putting to the test. The claim is that the average is 130 for systolic blood pressure of men ages 50 through 59. Now we're trying to use our sample to see, is the mean different from that? That's always the alternative hypothesis. What's the other case? Again, this is like usually what we think is true about the population compared to what is claimed about it.